Congratulations, everyone. This is the last video of new content. So the topic is called competition and payoff charts. It is most definitely a little tedious, but I wouldn't say that it's necessarily hard. So just give yourself some patience on this. It does take a little bit of time. Okay, the key to doing these problems is understanding the question. So it says there are 100 people in Manson that want to buy watermelons daily. Megan and Cody are in competition to sell their watermelons. They only have 75 each. Market shows that people will buy whatever watermelon is cheaper. And if the watermelons cost the same, Megan and Cody will split the customers. It costs Megan $100 a day to set up at Bill's Gas, and it costs Cody $50 a day to set up at the Apple Cup Cafe. Fill out the payout matrix below if each person sets their price at $3, $4, $5, and $6. So just to be clear, if Cody sets at 3 and Megan sets at 3, they have the same price. So if they have the same price, it says that they will split the customers if the watermelons cost the same. So in a situation like this, where we have 100 people that want to buy watermelons, if they split the customers, both Cody and Megan will both sell 50 watermelons. So what I like to do is, remember, Megan is going to be the first number here. This will be Megan's number, comma, Cody's number. So let's set this up as Megan is going to be $3. Okay, ooh, that was kind of funny. So it's going to be $3 times the number of watermelons she's going to make or sell. And then we have to subtract from Megan $100 a day. Cody is going to sell it for a certain amount of money, and he's going to sell a certain number of watermelons, but he only has a cost of $50 a day. So we've got to subtract that. So let's go back to this example of Cody at $3 and Megan at $3. So Megan will be at $3 and Cody will be at $3. And since they're the same price, they're going to sell 50 watermelons each because 100 people want to buy. So it's going to be 3 times 50 minus 100. And Cody's going to be 3 times 50 minus 50. So doing that math in my calculator, I get $50 for Megan and $100 for Cody. Okay, now let's do this situation here. This is when Cody sets at 4 and Megan sets at $4. So I'm going to change these to 4. But they're still going to have 50 customers each, right? Because they have the same price. So doing that math, I get Megan at $100 and I get Cody at $150. Okay, next is this one right here is if Cody and Megan are both at 5, since they're at the same price, they're going to split the customers again, 5 and 5. Okay, doing this math out, I get 150 for Megan, and I get 200. And you might be able to see this pattern, just continue with it. You certainly can do that if you want. But we've got next up is $6 for Megan, $6 for Cody. They both split 50-50. For those 100 customers, and that's going to give us a value of 200 and 250. I always like to do that diagonal first because remember, they're splitting. Okay, now let's go ahead and let's hit this one right here. If Megan's setting at $3 and Cody's setting at $4, what happens? Well, people are going to go and pay Megan for the watermelons because remember, market shows that people will buy whatever watermelon is cheaper. So if Megan sets, remember we're at this column right here, this one right here. If Megan sets at $3, hers is cheaper than if Cody sets at $4. So we have 100 watermelons, but they only have 75 each. So Megan's going to sell all 75 of hers because hers are cheaper. And Cody's going to be left with the 25 other customers. So we go ahead and we do that math, and we are left with 125 for Megan and 50 for Cody. Okay, let's try this one right here. This time Megan is still at $3 and Cody this time is at $5. But Megan's still going to get the 75 customers first because hers are cheaper at $3. So we do that math and I'm left with 125, 75. And last one here in this row is, again, Megan is still going to be selling at $3 and she gets the 75 customers first, but she runs out because she only has 75 watermelons. So the other 25 people go to Cody, and now he's actually selling it at $6 and he makes more money there. So for this one here, I get, again, Megan at 125 and Cody at 100. All right, let's go to the next one here. And I like to kind of erase these. So here we're at Megan at 4 and Cody at 3. So Megan's at 4 and Cody's at 3, which means Cody's, since he's cheaper, he's going to get 75 customers, then run out of watermelons, and then Megan gets the remaining 25 customers. So doing that math, I'm left with $0 for Megan and 175 for Cody. All right, next one, let's take a look at this. Here, Megan's at 4 and Cody's now at 5. Well, who's cheaper? Megan's cheaper, so now she's going to go to 75 customers, and then Cody gets the remaining 25 because Megan runs out after 75 watermelons. And that's going to give me 200 for Megan and 75 for Cody. Okay, let's do this one right here. Here we are left with Megan at 4 and Cody's at 6. So same situation where Megan is cheaper, so she gets the 75 customers first, then Cody gets the remaining 25. So doing that math, I get 200, 100. Okay, now let's go ahead and look at this one. So who's cheaper? Looks like Cody's cheaper at $3. So Cody at $3 is going to get 75 customers. Megan at $5 is going to get 25. And that's going to give us 25, 175. Okay, taking a look at this one right here, Megan is still at $5 and Cody is now at $4. Cody is still cheaper, so he gets 75. Megan gets 25 customers, and that's going to be 25, 250, or 250 if you're cool like me. All right, last one here on this row, we're going to have Cody at 6 and Megan at 5. But now Megan's cheaper, so she's going to get the 75 customers. Cody gets the 25. Doing that math, I get 275, 100. Almost done, folks. Stay with me. All right, last one here in this row, we've got Megan at 6, Cody at $3. We're talking about this one right here, which means that Megan's going to get only 25 customers because she's expensive, and Cody gets 75 customers. Doing that math, I'm left with 50, 175. Okay, next up, Megan's still at 6, and Cody's now at 4. So that's all that changes for this box right here. So Cody still gets more customers because he's cheaper. So he is left with $250 and Megan gets 50. Okay, last one here. Megan's still more expensive even when Cody jumps to $5, and so that's going to give him $325, quite a bit of money, but Megan's only has 50. All right. So I just kind of typed those in there. That's the same answers that we just got. So here's the question. If Cody sets his price first, what should Megan do? This is not realistic where Cody's like, hey, I'm going to show my cards and tell you what I'm setting at. But if he does happen to do that, then Megan should make a smart move. So if Cody sets at $3, should Megan take the 50, 25, or 50? Well, she should set at either $3 to get the 50, or should set at $6. Okay, so either. She should set at either. What about if Cody sets at $4? What's the most money that Megan can make? $125, $100, $25, or $50? Well, she's going to want to go and set at $3 because that's going to make her the most money at $125. Okay, what if Cody sets at $5? Do we prefer $125, $200, $150, or $50? Well, clearly setting at $4 is going to give us this $200, so setting at $4 is the best. All right, now what if Cody sets at, what if Cody sets at $6? Megan's options are $125, $200, $275, or $200. In this case, we should set at what? What's the most reasonable? $275, so Megan should set at $5. Is there a Pareto optimal solution? Here's the definition you should get down. It is a Pareto optimal solution if and only if, that's not spelt wrong, that's just how you spell if and only if no move can be made that helps a player without hurting another. Well, let's see if this is a Pareto optimal solution. So Megan's at 25. She might say, hey, let's actually go over here. And Cody says, yeah, sure, no big deal. It doesn't hurt me. I stay at 250. So it brings Megan up. So that's a good case. What if we're left, I don't know, say here? Well, Megan will say, hey, can we jump here? Because I'll get 200 and you'll go from 75 to 250. And they'll be, oh, yeah, sure. So, ultimately we end up here. And the question is there a possible move that can be made that helps both players? Well, in this case, Megan wants to move here to $5, but does that help Cody? Cody's going to say, no way, because I know you're going to make $25 more, but I'm going to drop a ton. So he says, I'm not moving. Cody says, well, hey, look at this. I've got 250. I could get 325 if we move over here. Megan says, absolutely no way. I'm going to go from 200 to 50. So if you look at this case right here, this is a Pareto optimal solution because no move can be made that helps a player without hurting another. So this is the Pareto optimal solution. And almost always it's located in that bottom right corner. Okay, we've got one more example here, and yes, it's a little bit faster. And remember, I like to set these up as the S Sorensen being the first. So we're going to have Sorensen is money times the number of something minus something. We'll deal with that in a second. Johnson's going to be money times something minus something. Okay, let's understand the question. Ms. Sorensen and Ms. Johnson start charging students to take their classes. There are 40 students that need a math class. Each teacher can only take 30 kids. Research shows that people will take the class from the cheaper teacher. It costs Ms. Sorensen $50, so I'm going to put minus 50, $50 of expenses during the year, and Ms. Johnson $100. Fill out the payout matrix below if each person sets their price at 20, 30, or 40. Well, it didn't say in the problem, but you should assume that if both teachers set their price for the same amount, they're going to split the kids. So in this case right here, in these, we are splitting the kids. So we're at 20-20, and then we're both at 30-30, then at 40-40. But let's first focus on this 20-20. So we're both going to set the price for 20, and we're going to split the kids. There are 40 students, and since we've got the same price, we're going to have 20 students in both of our classes. So there we're going to have 350 for Sorensen, just doing that math, and then 300 for Ms. Johnson. Okay, now let's do this one. It's the same exact thing. We're going to split the students 20-20, but now we're at $30 per student. They're going to pay $30, and Ms. Johnson's students are going to pay $30. And so here we're at 550 and 500. Okay, here we are in this situation where we're both going to charge $40 to each student to enter our classes. And since we're charging the same amount, we both get 20 students because we split them. And here we're left with 750 and 700. Okay, now we kind of have to go into the situation where we're not having the same price. And keep in mind that we can only take 30 students by our contract, right? We can't take more than 30 students. So in this case right here, who's cheaper? Miss Sorensen is at $20 and Miss Johnson's at $30. So Miss Sorensen's going to get the 30 kids because she's cheaper, but then she can't take any more than 30, so Miss Johnson gets the 10 students left over. So doing that math, we are left with $550 and $200. So Miss Sorensen $550, Miss Johnson $200. All right, next here we've got Miss Sorensen at 20 still, and Miss Johnson is going to be at 40. And since Miss Sorensen is still cheaper here, she's going to get the 30 students again, and then Miss Johnson gets those leftover 10. So doing that math, I get $550 and I get $300. Okay, let's go to this one right here. So in this situation, we have Miss Sorensen at $30 and Miss Johnson at $20. Miss Johnson's cheaper, so she gets 30 students and Miss Sorensen gets 10. Okay, doing that math, I get $250, $500. All right, here we go. Here, Miss Sorensen's still at $30, and Miss Johnson is now at $40 though. So who's cheaper? Miss Sorensen's cheaper, so she's going to get the 30 students, and Miss Johnson's going to get the 10, the leftover 10. And so here we're going to be left at $850, $300. All right, let's do this one right here. And that's going to give Miss Johnson's going to be at $20, Miss Sorensen's going to be at $40. And since Miss Sorensen's expensive, she's going to only have 10 students, and Miss Johnson's going to have the 30. So doing that math, we're left with $350, $500. Okay, last box here, we're left with Miss Sorensen at 40 still, and Miss Johnson's going to be at 30. Again, Miss Johnson's cheaper, so she's going to get 30 students. Miss Sorensen gets 10, and that math becomes $350, $800. Remember, the $350 stands for Miss Sorensen's amount, and the last number stands for Miss Johnson's amount. So I just kind of retyped this for you, and we've got to answer this question. If Miss Johnson sets at $20, what should Miss Sorensen do? Well, she should either set at 20 or she should set at 40. The 350s are the best. If Miss Johnson sets at 30, $550, $550, $350, we should set at $20 or at $30. Either is fine. Okay, what if Miss Johnson sets here? We've got an option of $550, $850, $750. Definitely Miss Sorensen wants to set at $30 to get that $850. All right, next question. Is there a Pareto optimal solution? Well, we should always look here first. And let's see where Miss Sorensen would convince Miss Johnson to go. The only way for Miss Sorensen to do better here, 750, is for her to jump to 850 right here. And so she's going to try to convince Miss Johnson to go to that box, but Miss Johnson's going to say, no way, Jose, because I'm going to lose $400. I'm not doing it. So then Miss Johnson says, well, hey, Miss Sorensen, I can actually make $100 more by going here. That's my only better situation. You want to go there? She's like, heck no, heck fire no, because 750 to 350 is a huge drop for me. So yes, this is a Pareto optimal solution. All right, thanks for listening, everyone. Congratulations on finishing the Math 130 curriculum.